In our videos so far, we've had a look at the scramjet engine as a whole and all its different systems and how they fit together. And I hope from these videos that you've gained a picture of what these different systems are, what some of their problems are, and some of the methods which engineers use to overcome these problems. All the way through the videos, I've emphasized the importance of the air-fuel mixing as being a critical part of the engine. And before we embark on a study of this, I would like to make a few preliminary remarks just to illustrate and underline these points and why this system is so important to the performance of the engine as a whole. At the immense speeds that we're talking about, drag is huge, and I've already emphasized that designing the engine and indeed the whole vehicle to be low drag is absolutely critical to its performance. The drag is much higher than, for example, a supersonic fighter aircraft, even with our very best designs, because we're traveling so much faster than it. So maximizing the thrust to overcome this drag is of critical importance, and to maximize the thrust we must get the maximum energy from the fuel. Also, the flow entering the engine is already very hot because it's had to slow down, and therefore adding more heat to this already energized flow is difficult. So, both these facts mean that to have any chance of succeeding in producing a working engine, all the available chemical energy from the fuel must be converted into thrust. To do this, the air and the fuel have to be mixed completely at the molecular level, so that the molecules of air and the molecules of fuel are in close contact with each other. And this means that they can't be just mixed roughly or macroscopically, which is the case with most internal combustion engines. The mixing must be much more thorough. However, the flow passes through the engine in a couple of milliseconds, and therefore the mixing must take place within a few microseconds. And after that, the resulting supersonic flow must be ignited and the flame sustained somehow. So this in a nutshell is why mixing is so important and why it is so difficult. It has proved to be the most difficult obstacle to overcome so far in the design of scramjet engines, and is a principal reason why very few of them have shown any sort of measurable thrust up until now.